Alright, so for this, we have a question to graph y equals 2 cos of 2x. And the thing about this year's trigonometry compared to last year's trig is that the x-axis is a different unit. So you'll notice that we've been using pi instead of degrees, like we used to. So we have radians replacing degrees, which doesn't really change too much, but it just makes it maybe a little more complicated depending on how you look at it. Maybe if you're not used to radians, it might be a little trickier, but for the most part, it should be the same. So there's two main ways you can graph an equation. You can either graph the base function and just add transformations on top of the drawing. So for example, if I want to draw a cos, this is just some random example, I'd go like this, and then maybe in a different color or something, I'd do the amplitude, and then I would do the period. And I would just keep doing new drawings with new transformations. But instead, I think it's easier and faster if we just do a table of values and graph the new thing just once. So what that would look like would be, we'd do two table of values. Now the first table of values is going to be the table of values for just your standard y equals cos x. And for the second one, it's going to be with the transformations. Alright, so let's start with the first table of values. So we have at 0, your cos is always going to be 1. Then at pi over 2, it's going to be 0. At pi, it's going to be negative 1. 3 pi over 2, it's going to be 0. And then 2 pi, it's going to go back to 1. This is going to be your default cos parent table of values that you're always going to have as a reference. And this is something that should be practically memorized by now. So now, for the transformations, so for the second table of values, we have to assess what transformations affect the x and what transformations affect the y. So when looking at our new equation, we can see that we have an amplitude of 2, which we know is a vertical stretch, which affects the y. And then we also have a 2x, which is a horizontal compression of 2, which affects the x. And what we could do, since we have this, is say, well, for every y value, we'd multiply it by 2, and then for every x value, we divide it by 2. So now you kind of just plug in all your table of values from your parent function, your parent function into this new one, but you apply the transformations on the table directly. So let's start off with the y values on the right. So first, we have y equals 1 right here. So if we put it on the right side, we would do 1 times 2, which is 2. So we have 2. Then we move down 1. So then we're at 0. 0 times 2 is still 0. Then we move down again, negative 1. Negative 1 times 2 is just negative 2. Down again, 0. And then 1 we already did at the start, which is 2. And we already have our y values done. Those are finished. Now for our x values. So 0 divided by 2 is just 0. Pi over 2 divided by 2 is pi over 4. Pi divided by 2 is just pi over 2. 3 pi over 2 divided by 2 is 3 pi over 4. And then 2 pi divided by 2 is just pi. So now we already have our full table of our transform function. So now we can simply graph it. So when x is 0, y is 2. So at 0, y is 2. Perfect. At pi over 4, our y is 0. Now sometimes if you have a graph like this where you can't create your own scale, I guess you could say, you kind of have to sometimes estimate, but sometimes you can also just figure it out. Like, for example, if our function is being divided by 2, or horizontally compressed by a factor of 2, and we have pi over 2 over here, then we know half of that, which is about here, is pi over 4, because that's half of pi over 2. And at pi over 4, y is 0, which would go right here. So that's that point done. Now we can look at our next point, which is pi over 2, it's negative 2. So at pi over 2, we're at negative 2. And you can see that it's going to constantly just go up by 2.5 boxes on this specific scale. So we have 1 box, 2 box, half a box. Then we got half a box, 1.5, 2.5, and it's just going to continuously do that. So this next point should be 1, 2.5. So right here, this should be 3 pi over 4. And at 3 pi over 4, our function's at 0, which is right there, 0. And then finally at pi, it's back at 2. It's back at 2. And you can draw a rough sketch of your new function. And now you've successfully graphed one cycle of your new function. And you can also graph as many cycles as you'd like, or if someone's, let's say, requesting 2 cycles. So because this is one cycle, and you want to graph another cycle, you treat this endpoint back as the start point for your first cycle. So you just repeat the same process. So so if this point over here is this point, then you know that this next point is going to have to be on the same y value, on the same y-axis, but just move 2.5 boxes to the right. So from this point, we go 1, 2.5, and then straight down to the same, straight down to the same point. Make this red. I'll get rid of the line. There. So now you kind of do the same thing. Or another way to do it is, since you know that from the start to the end of one cycle, it's pi, that's the period, and you can find that using your k value, or you can look at the graph, then each point is going to be a pi away from each other relative to its next cycle. So this point here is a pi away, I change the color, this point here is a pi away from this point here. That means this point here, pi over 2, is going to be a pi away from the next point, which is going to be down here. Then this point is going to be a pi away, so it's going to be 1, 2.5, back up, and then 1, 2, 3, and then back up here. And then you can graph your second cycle. Alright, so now let's try to graph something a little bit harder maybe. So I'm going to reuse the same image from the top. And now we are going to come up with a new graph, a new equation. So let's say graph, let's change it this time. Let's do y equals negative 0.5 sine of, let's do 4x plus pi minus, plus 2. Let's try to graph something that looks like that. So first thing to do, check if you can factor something. In this case, you can factor this. So we're going to rewrite that as y is equal to 0.5 sine. We're going to take out the 4. It's going to become 4x plus pi over 4, because now we're dividing that pi by 4, plus 2. Now we have this. So now we can do our table of values. So here we have our y is equal to sine x, And then here we have our y equals whatever transform function that we have that we're trying to graph. So for y equals sine x, you have your 0, pi over 2, pi, 3 pi over 2, 2 pi. Those are your main important points. And then for sine, it goes 0, 1, 0, negative 1, 0. So those are going to be your main points for your x and y. So now you transform those over with this. So for again, you look what affects the y and what affects the x. So moving left to right, you have the negative, which affects the y. You have the 0.5, which also affects the y. And all the way on the right, you have the plus 2, which also affects the y. Now, the 4 and the pi over 4 are going to both affect the x. So when writing the transformations for our second table, for the y, we can do times negative 1, then times 0.5, and then add 2. We're multiplying by negative 1 because we're trying to flip the y values down on each other because it's a reflection over the x-axis. So 4 becomes a negative 4, and negative 3 becomes a 3, which is why we multiply by negative 1. And then multiply by 0.5 because we are compressing the graph vertically by 0.5. Or sorry, we're stretching it by 0.5, so we're compressing it by a factor of 2. And then we add 2 because everything will shift up by 2 because of our c value. Now for our x, we have divided by 4. And now the x plus pi over 4, so it's going to shift to the left by pi over 4, which means we're going to do minus pi over 4. And then that sign gets a little bit confusing, the whole x plus phase shift or minus phase shift, but it would get some time to get used to it. So now let's do the same thing that we did before. So let's just start with our y values. So we start off with 0. I'm just going to work down here for the first couple numbers. So we have 0. And so yeah, so we're working with the y. So we're going to multiply by negative 1, which is just 0. Multiply it by 0.5, which is still 0. And then add 2, which is going to be 2. So our first y value is going to be 2. Then we have 1, so multiply that by negative 1, we get negative 1. Negative 1 times 0.5. That's going to be negative 0.5. Now negative 0.5 plus 2 is going to be 1.5. And then we go back to 2. That's going to be a 0 down there, so we do 2 again, and then negative 1. We can do negative 1 times negative 1, which is 1. 1 times 0.5 is 0.5, and 0.5 plus 2 is 2.5. Now for our x values, now it's faster to do this on a calculator, which is what I'm going to be doing. I have a calculator right next to me. So the 0 is going to just be 0 divided by 4, which is 0. Now 0 minus pi over 4 is minus pi over 4. Then you have pi over 2 divided by 4 minus pi over 4. So yeah, sorry, this is going to be negative pi over 8. And then we're going to move down, so we got the 0, 3 pi over 2. We're going to have pi over 8. And if you recognize the pattern, then the next point is going to be pi over 4. There. And so now we can work on graphing this. So we're just going to ignore the scale for now. I'm just going to simply get rid of this so we can make our own scale. So At negative pi over 4, we have 2. So let's have negative pi over 4 be, let's have it be right here. So we have negative pi over 4. We have 2. At negative pi over 8, we have 1.5. So I'm going to have that be right next to it. At negative pi over 8, we have 1.5. So this is going, if this is 1, so 1.5 would be here. This is 1.5. And then at 0, we have 2. So 0, 0, back up to 2. And then at pi over 8, we have 2.5. Which is going to be up here. Sorry, not that, up here. And then at pi over 4, we're back down to 2. So this is what our function would look like if we had our scale shaped that way. And you could have your scale be like for every tick it's by 2 or by 3, 2, 3, or 4 or 5, like one whole grid box, however you want to shape it, as long as it works. So that is, for the most part, the whole lesson of transformations, the 3 main types of graphs, turning graphs into equations, and equations into graphs.